welcome to Coding with Tom. Today we'll be using gestures in SwiftUI. We'll use a gesture to add drawings, then we will add a gesture to drag the drawings, pinch the drawings so we can scale them, and at the end we will add an animation to dismiss them. We will be using a new app for this exercise. Our main view is going to be called Canvas. In here we will be drawing and managing all of the shapes. When you want your view to be the entire size of the screen, one nice trick to do it is to use a C-stack. And the first bit that you're going to add is going to be a shape, and we just had the fill. Right now we'll use a green color just so we can distinguish the view, but later on we will change it to clear. After the shape, we just add a for each of the shapes, which are going to be represented inside of any view. And our gesture, it comes in forms of a modifier, which is on tap gesture. Now when we tap, you can see that the content is being printed. Now we want this to happen when we tap twice, so we add count. Let's tap 2 times, and there we have our print. What we really want to do in our gesture is add shapes. Each time we tap twice, a new shape is added. Right now we're just going to hard code adding a circle with a specific fill color and a frame. Let's run here and see how this looks. So we tap twice, and here's our circle. Let's now change the fill color to clear and run again. Now let's try tapping. Nothing happens. No shape is being added. Now, why is this? This happens because when we change the color to clear, we lost the content shape. There's nothing to be tapped. So for that, we need to add another modifier, content shape, which is precisely for hit testing, and the shape is going to be a rectangle. Let's try once more. Tap twice. Here's our circle. Right now we cannot see the other views that we are adding because all of them are being added to the center and they are the same color. What if we could drag them? Let's create a draggable modifier. And here what we will add is to each shape, we will add it so that when we drag, the view goes with the user's finger. What's known in UIKit as the UI pan gesture recognizing is the equivalent in SwiftUI to a drag gesture. For a drag gesture, you can add 2 modifiers. One is on change, every time the user moves the finger, and ended, which is when the user lifts the finger. So we know that the gesture starts when previous translation doesn't have a value. And when it's changing, we will calculate the delta comparing with the previous point of the user's finger. So we calculate the difference of these translations, both in the X and Y coordinates, and then we apply that value to the offset. After these calculations, we update the previous translation with the current translation of the gesture. We apply this to the offset modifier. Now, we could add this as with the modifier, but we want the views to call this, so we will add the function Draggable as an extension of view. And when we call this, we apply the Draggable modifier to the view. So it's a little bit nicer to read. Let's add this to each of our shapes inside the for each and run. You have a view. Let's drag. And we can do it. This applies for every view that we add. Now that we have the drag gesture ready, let's play with adding different shapes with different colors. Right now we have our hard-coded circle. What we're going to do is call a class that will give us a random shape. To generate the random shapes, we will just generate a random int between a certain range, and depending on that value, we generate some shapes. Right now we just have two shapes. One is the circle and another one is a rectangle. So we'll have just two random numbers. In our canvas view, now instead of the hard-coded circle, we'll add the random shape each time. Let's call it, oh, I used the wrong name for the class, by the way. It cannot be shape. Let's add an S, since shape is already a protocol for SwiftUI. So shapes that get random shape, and that's it. Now we could add another one, since rectangle can also be a square. So for our third number, we'll add a real rectangle where the width is different than the height. And then for a random color, we just have an array of colors, and then we use the function random element. When we double tap, I can see here we have a square, a rectangle, here's a circle, and each of them is draggable. Moving on, let's add another shape. Let's add a triangle. So now our fourth number will generate a triangle. We will see here we are not getting the triangle completed, and that's because that shape is not provided by default in SwiftUI. We need to create it ourselves. Now triangle will not be a view, it will be a shape, and this protocol requires us to add this method path. So this one provides a path, which is very similar to UIGestureRecognizer path. So we move the path to the point 0, and then we add the three lines that will conform a triangle. Instead of adding the last line, we can just close the path, which will automatically add that line. Let's see how it looks. Now you may notice that the triangle is upside down. This is because the coordinate system here is different, and 0, 0 is in the upper left corner. Now we can use the triangle shape here. There's our triangle. Our next Swift UI gesture will be the equivalent of UI pinch gesture recognizer, which we will use to scale up and down the shapes. So for pinching, we will use magnification gesture. And just like for the drag gesture, we can add two modifiers, which is the onChange and onEnded. To calculate the scale, we'll use the distance between the user's finger while they are pinching, and for this we use the magnitude attribute from the gesture. To modify the scale of the view, we use scale effect. Just like we did for drag gesture, we'll create an extension of view that adds this modifier, scalable. We'll also add this to the shapes and run. Let's try enlarging this one. And oh, we are scaling up and down the shape, but it is doing it at a higher rate than we expect. Here is the culprit in the code. I forgot to set the previous scale value after calculating the scale. Let's try now. By the way, to have this pinch gesture, you use Option, and then to move the fingers without spreading them more, you hold down Shift. Okay, so our views are getting scale up and down, but there's an offset. Let's try for our triangle. It's the same. It's not centering. So even though we are achieving what we want, it is not doing it so smoothly, and it doesn't look well. Let's try and fix it. Something that I can think of is the anchor point is not being set in the center, and that's why we have the offset. So let's add it explicitly in the scale effect and run again. Or let's do it for our square. Okay, it seems to be working. Let's try it with the rectangle. And oh, again we have the offset. So the anchor point wasn't enough. Okay, I think I got it. What we need to do is not add the modifier separately. What we need to do is add one modifier that's aware of both gestures. That way we can have them in sync, both the offset for the draggable and the scale for the pinching. We are not done yet, but let's create the extension for the view. So we'll be adding another method, draggable and scalable, and it will add this new modifier that we are creating. Now, instead of having them in different modifiers, let's create variables for these gestures. So one for the drag gesture and another one for the scale gesture. And for now, let's just add the drag gesture. It can still drag. Okay, everything's fine. Now, let's add another modifier to our gesture, which is this. It can be sequenced, as in we'll first add the drag gesture and then the scale. Let's try running. With the square, we can drag it. Let's try pinching. Nothing happens. Okay, I found out what was going wrong. I was using bad this sequence. This one actually needs the previous gesture to succeed, and then it executes the other one. meaning that we will have to have a gesture that does something and then the other one, which is not the case for dragging and pinching. It's either one or the other. So what we want is not sequence, what we want is simultaneously. So we'll have the drag gesture and it will interact simultaneously with the scale gesture. Let's try it with these two gestures. We can still drag. Let's try pinching. Okay, looks good for the circle. Let's go for the square. It also works, no weird offset. The triangle, this one was giving us trouble before. Okay, everything good. And the rectangle, perfect. Okay, now for our last gesture, what we want is that when the user taps twice with two fingers, we're gonna remove all of the shapes. Unfortunately, we cannot do this with a SwiftUI gesture since the functionality to specify the number of touches, not taps, has not been added to those. So what we need to do is use UIGestureRecognizer to add a UI tap gesture recognizer, since for those we can specify the number of taps and touches. So we're going to create this two-finger gesture view. We'll have a coordinator. We need a coordinator because for UI gesture recognizers we need to add a selector, and those are only supported in classes, not structs. If this is your first time seeing UI view representable, you can use here something that's called coordinator. So you create one class, and this you can use it to whatever UI view you are creating here, which needs a delegate or something similar. In this case, the class that has the selector, but this could also work for a delegate of a UI table view or UI collection view. So you specify this in the make coordinator, and then you can retrieve it from the context later. Since we have the UI tab gesture recognizer, we can specify number of touches required, which is 2. As I mentioned, you can retrieve the coordinator from the context, and that's when in the make UI view is when we will call the method that adds a gesture to the view. Then we add this in our C stack. We're gonna add it below all of the shapes that we're doing. So we haven't messed with any of the existing gestures. We can pinch, we can drag. Now let's try tapping twice. And we have our print, so it's working. Let's make our modifier more flexible. So we'll specify the number of tabs in the init, which will also be using the coordinator. And then when we add the gesture to the view, we now also set the number of tabs required. Instead of printing, now what we do is with an animation closure, we set the array of shapes to empty. Let's tap twice, and our views are removed. Now we could leave it here, but I want to animate the removal of those views, not just with them fading out, but actually I want it so it appears as if they leave the view from the edges. So what we're gonna do first, let's create a modifier that will pass just two values, the offset and the opacity, and that's what it does to the view. With this modifier, now we apply the transition modifier to each of the shapes, and we use the dot modifier. This one, What it does is you pass two modifiers, the one that it has when it's active, meaning when the transition is happening, and the one with the identity, meaning when it is on screen. So here, I made a mistake actually. The active should be when it's leaving, so the opacity is 0. The identity will be 1. And for the offset, let's get a random offset. So we'll return a CG point with a random value between minus 500 and 500 for the X and Y coordinates. And with this, I think we are done. Let's try it out. Let's add some shapes. And they're animated out. Let's add more shapes and try again. And let's tap again. We did it. That was all for today. Using gestures in SwiftUI, it's a little bit challenging, but doable. For some things, like number of touches, you need to rely on UIGestureRecognizer, but with UIB representable, it isn't that hard. That was all. Hope you liked it. Bye.